Hello! Now I can't promise I'm going to do this every time, guys, but here we go. We're going to do today's do now. I've done some little changes. Some of you guys who were in class today, you may realize that I've noticed pretty quickly that I made these kilometers. And I made these kilometers, just because Mr. Shaw enjoys a good unit conversion. Now, we have a student walks 6 kilometers north, 3 kilometers east, then 2 kilometers south in 5 seconds. What is the student's average velocity? And you'll see average velocity more often than not look like this and be part of this formula, where this is displacement, very important, this displacement, this is displacement. And displacement is a straight line from where you start to where you finish. Straight line, remember that. It's a straight line from where you start to where you finish. This is your time. And obviously the V, like I said before, average velocity should be a V. I don't know, for some reason with this drawing thing, always comes out looking like a W, or a lot of times. So, let's do an initial drawing just to give ourselves a good idea. We're going to go 6 kilometers north, and let's actually do this with the vector tool. That should be fun. We're going to go 6 kilometers north, and then we're going to go 3 kilometers east, then we're going to go 2 kilometers south, so it's like this. There we go. Now this is not perfectly to scale, this is about as best as I could do, but we should easily be able to see what the resultant's going to look like. Nope, don't change that one. Let's pick this, and go back, and then pick a red one. The resultant should be something kind of like this. Now, what you guys should immediately remember from this particular problem is that you will, I always do that, you will make a triangle out of this. Let's make it a better triangle. There we go. And this is a right triangle. Don't move that. Don't move that. This is a right triangle, meaning that if we find the sides, we can use trig functions and Pythagorean theorem, all kinds of fun stuff. So once again, this is going to be 6. The whole thing is 6. I'll put it further out for those of you guys who remember. This is going to be 3, and this is going to be 2. I'll put my units on there. Don't yell at me. Don't yell at me. Now, what you should notice is that if you could just remove this shape right here, you'll just have a triangle. That's so easy. So this is 2 down, so that makes actually just this side, screw you, get off there, just this side to be 4 km. And then this side is just going to be 3 km. Okay, and if you guys notice from your geometry classes, a 3, 4, 5 triangle. And what you'll end up doing is you'll want to convert this to meters. Now remember, how do you do that? Want over half. And once again, this is an added step from your do now. This wasn't in the original. It's just because I love doing these. These are my fave. So, we're going to figure out, remember, K, find that on your reference table or probably on the board. And that's going to be 10 to the third. And what you'll remember is you need to go back and let's, no time now to do what I want. Remember, you're going to add something here. That's going to be meters, and then you're going to make this an equal sign, and you're going to make this meters as well. So you've got 1 kilometer, that's 1, equals 10 to the third meters. Now, the next step, you're going to take these things and plug them into that. So, what is it that we want? We always want meters, guys. What is it that we have? Unfortunately, we got kilometers. And then let's just plug in our numbers. We've got 1, 10 to the third. And you're going to take that and multiply by your 5 kilometers. And you're immediately going to see these guys cancel out. Get away kilometers. And you're left with 5 times 10 to the 5th. I'm sorry, not to the 5th, to the third. 5 times 10 to the third meters. Now, this is your displacement. Remember, displacement is a straight line from where you start to where you finish. And that is our displacement. And you're simply going to plug it into this formula. V equals 5 times 10 to the third meters over 5 seconds, given to us from the problem. Right there. And this is our average velocity. And you should end up getting an average velocity equal to 1 times 10 to the third meters per second. Okay, not so hard. Let me show you real quick another way of doing this. Now remember, let's just remember what we did. We went 6 up, 3 to the right, and 2 down. So let's just draw this. I may run out of space here a little bit, but I'm going to go 6 up. That looks like about 6 up. And then I'm going to go, let me flash back. I'm going to go 3 east. So I'm going to come here, 3 east, and then I'm going to go 2 down. And 2 down. Okay, so you see I've got 3 different vectors here. A little hard to see, but we can get this done anyway. Now remember, this one went 6 up. What do you think that the point right there is? Well, that's going to be, I went wrong. That's going to be 0, 6. It's on the y-axis. It has a x value of 0 and 6. Then let's take a look at this guy. Well, he's at 3, 0. You'll say, Mr. Shaw. And then you look at this guy, and he's at, I always want to do this, I'm going out of order, 0, -2. So what we can do is just simply add these 3 locations up. So we are going to have 0, 0, and 3. 0 plus 0 plus 3. And that's going to give you, obviously, 3. That's our x term. And then -2 and 6 is going to give you 4. And that is our y term. That was, once again, 0 plus 6 minus 2 gave me 4. That's where I got that from. So this is my x, and this is my y. So that's going to put us at 1, 2, 3, 1, 2, 3, 4, right there. And if we draw a vector there, so many vectors already there. That's the resultant of these 3 vectors added together. And you could just simply do, well, you could just make a triangle and find the length of that side. Wouldn't be too difficult. You know it's going to be, I always forget that. It's going to be 4 on this side and 3 on this side. 3, 4 triangle. This side will be 5. So that's just another way of thinking about the problem. Okay, guys.